SpaceX likely to get FAA approval for 25 Starship launches in 2025. SpaceX wants to ramp up flights of its Starship mega rocket next year, and regulations apparently won't stand in the way. On Wednesday, November 20th, the U.S. Federal Aviation Administration, FAA, released a draft environmental assessment, EA, of Starship operations at Starbase, SpaceX's facility in South Texas. The 160-page document, which you can read here, approves the company's request to boost the number of annual Starship liftoffs from Starbase by a factor of 5, from the currently allowed 5 to 25. SpaceX's reported launch target for 2025. The draft EA also approves 25 landings for both Starship elements, its Super Heavy booster and ship upper stage, back at Starbase. These landings would occur at the launch tower, which would catch the returning vehicles using its chopstick arms. SpaceX has achieved such a catch once, snagging Super Heavy during the 5th Starship test flight on October 13. SpaceX is developing Starship, the biggest and most powerful rocket ever built, to help humanity settle the Moon and Mars. The 400-foot-tall, 122 meters, vehicle is designed to be fully and rapidly reusable, and SpaceX plans to eventually conduct multiple Starship launches per day. The stainless steel mega rocket has launched 6 times to date, all of them test flights from Starbase. The most recent liftoff, which occurred on Tuesday, November 19, was a success, though a communications issue prevented Super Heavy from coming back to Starbase for a chopsticks catch. Instead, the booster diverted to perform a controlled splashdown in the Gulf of Mexico. The newly released EA is just a draft, so its findings are preliminary. The FAA will hold 4 in-person public meetings in South Texas, 2 apiece on January 7 and January 9, and 1 virtual conclave on January 13 to discuss the EA. SpaceX and its founder and CEO, Elon Musk, have complained about the FAA a lot recently, claiming that the agency has stifled Starship's progress, and the American launch industry overall, with overly burdensome regulation. Companies in the spaceflight sector, and in most if not all other industries, will likely have freer rein to do as they please after President-elect Donald Trump takes office in January, and Musk will have a say in this effort. Trump has appointed the billionaire entrepreneur to co-lead the Department of Government Efficiency, an advisory group that aims to help dismantle government bureaucracy and excess regulations. Ready, set, action. Our sun is the star in dazzling simulation. NASA supercomputers are shedding light on what causes some of the sun's most complex behaviors. Using data from the suite of active sun-watching spacecraft currently observing the star at the heart of our solar system, researchers can explore solar dynamics like never before. The animation shows the strength of the turbulent motions of the sun's inner layers as materials twist into its atmosphere, resembling a roiling pot of boiling water or a flurry of schooling fish sending material bubbling up to the surface or diving it further down below. Our simulations use what we call a realistic approach, which means we include as much as we know to date about solar plasma to reproduce different phenomena observed with NASA space missions, said Irina Kitiashvili, a scientist at NASA's Ames Research Center in California's Silicon Valley who helped lead the study. Using modern computational capabilities, the team was able for the first time to reproduce the fine structures of the subsurface layer observed with NASA's Solar Dynamics Observatory. Right now, we don't have the computational capabilities to create realistic global models of the entire sun due to the complexity, said Kitiashvili. Therefore, we create models of smaller areas or layers, which can show us structures of the solar surface and atmosphere, like shock waves or tornado-like features measuring only a few miles in size. That's much finer detail than any one spacecraft can resolve. Scientists seek to better understand the Sun and what phenomena drive the patterns of its activity. The connection and interactions between the Sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts, auroras, and many other phenomena. Space weather predictions are critical for exploration of space, supporting the spacecraft and astronauts of NASA's Artemis campaign. Surveying this space environment is a vital part of understanding and mitigating astronaut exposure to space radiation and keeping our spacecraft and instruments safe. This has been a big year for our special star, studded with events like the annular eclipse, a total eclipse, and the Sun reaching its solar maximum period. In December 2024, NASA's Parker Solar Probe mission, which is helping researchers to understand space weather right at the source, will make its closest ever approach to the Sun and beat its own record of being the closest human-made object to reach the Sun.
NASA extended BioSentinel's mission in 2023 by up to an additional 18 months, or as late as November 2024, and again in 2024 by up to an additional 10 months, or as late as September 2025, to continue collecting valuable deep space radiation data in the unique, high radiation environment beyond low Earth orbit. Solar activity is expected to increase as we head into a solar maximum period in the Sun's 11-year cycle. Activity on the Sun, involving solar flares and giant eruptions called coronal mass ejections, are predicted to peak in 2025. These events send powerful bursts of energy, magnetic fields and plasma into space, which causes the aurora, interferes with satellite signals. Solar radiation events from particles accelerated to high speeds can also pose a threat to astronauts in space. The BioSentinel project builds on AIM's history of carrying out biology studies in space using CubeSats, small satellites built from individual units each about 4 inches cubed. BioSentinel is a 6-unit spacecraft weighing about 30 pounds. It houses the yeast cells in tiny compartments inside microfluidic cards, custom hardware that allows for the controlled flow of extremely small volumes of liquids that will activate and sustain the yeast. Data about radiation levels and the yeast's growth and metabolism will be collected and stored aboard the spacecraft and then transmitted to the science team back on Earth. A reserve set of microfluidic cards containing yeast samples will be activated if the satellite encounters a solar particle event, a radiation storm coming from the Sun that is a particularly severe health risk for future deep space explorers. In addition to the pioneering BioSentinel mission that will traverse the deep space environment, identical experiments take place under different radiation and gravity conditions. One ran on the space station, in microgravity that is similar to deep space, but with comparatively less radiation. Other experiments took place on the ground, for comparison with Earth's gravity and radiation levels. These additional versions show scientists how to compare Earth and space station-based science experiments, which can be conducted much more readily, to the fierce radiation that future astronauts will encounter in space. Taken together, the BioSentinel data will be critical for interpreting the effects of space radiation exposure, reducing the risks associated with long-term human exploration, and confirming existing models of the effects of space radiation on living organisms. Milestones: December 2021. The BioSentinel ISS control experiment launched to the International Space Station aboard SpaceX's 24th Commercial Resupply Services mission. January 2022. The BioSentinel ISS control experiment began science operations aboard the International Space Station. February 2022. The BioSentinel ISS control experiment began ground control science operations at NASA Ames. June 2022. The BioSentinel ISS control experiment completed science operations. The hardware was returned to Earth in August aboard SpaceX's CRS-25 Dragon. 4:29 p.m., November 22, 2024. Professor Azam Shani Maple Leaf, October 2022. The BioSentinel ISS control experiment completed ground control science operations at NASA Ames, November 16, 2022. BioSentinel launched to deep space aboard Artemis I, December 5, 2022. BioSentinel began science operations in deep space, December 19, 2022. BioSentinel began ground control science operations at NASA Ames, November 16, 2024. BioSentinel marks 2 years of continuous radiation observations in deep space, now more than 30 million miles from Earth. 4:29 p.m., November 22, 2024. Professor Azam Shani Maple Leaf, Partners. NASA Ames leads the science, hardware design and development of the BioSentinel mission. Partner organizations include NASA's Johnson Space Center in Houston and NASA's Jet Propulsion Laboratory in Southern California. BioSentinel is funded by the Mars Campaign Development (MCO) division within the Exploration Systems Development Mission Directorate at NASA headquarters in Washington. BioSentinel's extended mission is supported by the Heliophysics division of NASA's Science Mission Directorate at NASA headquarters in Washington, the MCO, and the NASA Electronic Parts and Packaging Program within NASA's Space Technology Mission Directorate at NASA headquarters in Washington.
What is BioSentinel? Astronauts lie in a pretty extreme environment aboard the International Space Station, orbiting about 250 miles above the Earth in the weightlessness of microgravity. They rely on commercial cargo missions about every 2 months to deliver new supply and experiment. And yet, this place is relatively protected in terms of space radiation. The Earth's magnetic field shields space station crew from much of the radiation that can damage the DNA in our cells and lead to serious health problems. When future astronauts set off on long journeys deeper into space, they will be venturing into more perilous radiation environment and will need substantial protection. With the help of a biology experiment within a small satellite called BioSentinel, scientists at Ames Research Center in California, Silicon Valley, are taking an early step toward finding solutions. To learn the basics of what happened to life in space, researchers often use model organisms that we understand relatively well. They have shown the differences between what happened in space and on Earth more clearly. For BioSentinel, NASA is using the very same yeast that make bread, rice, and beer brew. In both our cell and his cell, the type of high-energy radiation encountered in deep space can cause break in the two implied strands of DNA that carry genetic information. Often, DNA damage can be repaired by cells in a process that is very similar between yeast and human. BioSentinel set out to be the first long-duration biology experiment to take place beyond where the space station orbits near Earth. BioSentinel's spacecraft is one of 10 kW that launched aboard Artemis I, the first flight of the Artemis program space launch system. Powerful new rocket. The serial bauxite satellite traveled to deep space on the rocket and flew past the moon in a direction to orbit the sun. Once the satellite was in position beyond our planet's protective magnetic field, the BioSentinel team triggered a series of experiments remotely, activating two chains of the Saccharomyces cerevisiae to grow in the presence of space radiation. Samples of it were activated at different time points throughout the 6 to 12-month mission. One chain is the is commonly found in nature, while the other was selected because it has trouble repairing its DNA. By comparing how the two chains respond to the deep space radiation environment, researchers will learn more about the health response to humans during long-term exploration and be able to develop informed strategies for reducing potential damage during the initial phase of the mission, which began in December 2022 and completed in April 2023. The BioSentinel team successfully operated BioSentinel biosensor hardware, a miniature biotechnology laboratory designed to measure how living cells respond to long-term exposure to space radiation in deep space. The team completed 4 experiments lasting 2 weeks but did not observe any cell growth. They determined that deep space radiation was not the cause of the inactive cell, but that their lack of growth was likely due to the heat expiring after extended storage time of the spacecraft ahead of launch.
NASA's Curiosity rover captures 360-degree view of Mars and finds strange sulfur stones. The 360-degree view reveals new mysteries from the floor of the Geddes Vallis. For 12 years, we've watched Curiosity crawl its way over the rocky surface of Mars, decoding mysteries of the red planet and broadcasting back home pictures and data from the strange Martian environment. The Mars rover, built by NASA's Jet Propulsion Laboratory, JPL, has slowly scaled Mount Sharp since 2014. This mountain, officially Monique Red, Aeolus Mons, was discovered in the 1970s. Cut into its alien landscape is the boulder-packed Geddes Vallis Channel, which some scientists believe to be an ancient riverbed. Curiosity crossed into Geddes Vallis earlier this year, and, yesterday, JPL released a real treat for Mars lovers. A 360-degree panorama view of the Geddes Vallis Channel. The view shows a number of the Martian features that surround the Geddes Vallis Channel, including Kekenown Butte, Pinnacle Ridge, Texoli Butte and even a distant glimpse of Gale Crater Rim. Exactly how the channel came to be is currently up for debate among scientists. It's possible water flowed through it some eons ago, or that strong winds are responsible for the formation, or perhaps landslides cascading down from Mount Sharp's higher elevations created Geddes Vallis, which could explain the boulders and debris Curiosity has found along its trip. Among the debris are mysterious white sulfur stones, which are labeled in the panoramic view JPL provided. The rover also rolled over one of the white stones and cracked it open. Inside the crushed stone were yellow crystals of sulfur. Because the sulfur on Earth comes from hot springs and volcanoes, neither of which have been found on Mars, the JPL team has yet to come up with an explanation for the element's existence on the world. We looked at the sulfur field from every angle, from the top and the side, and looked for anything mixed with the sulfur that might give us clues as to how it formed, said Curiosity's project scientist Ashwin Vasavada in a statement. We've gathered a ton of data, and now we have a fun puzzle to solve. After over a decade of hard travels, Curiosity remains functional, if somewhat beat up from the tough Mars surface. The rover's next destination, a formation of web-like patterns called the Boxwork, lies further along Mount Sharp. First glimpsed in 2006 by NASA's Mars Reconnaissance Orbiter, the Boxwork spans 6 to 12 miles and could be the result of minerals carried by water into fractures along the mountain's surface. These ridges will include minerals that crystallized underground, where it would have been warmer, with salty liquid water flowing through. Kirsten Seeback, a Curiosity scientist who's studying the region, said in a statement. Early Earth microbes could have survived in a similar environment. That makes this an exciting place to explore. As Curiosity begins its journey to study the boxwork, JPL's scientists will use the data they've received to put together theories on how the features within the Geddes Vallis channel were formed. Now, the science team is forming a timeline of events, based on what Curiosity observed during its travels.